Good morning, everyone. I'm Uma Maheshwari from AP Department, R&D Engineering College. In this video, I'm going to give an introduction about the high voltage engineering, and the topic discussion is about mechanism of lightning. So we'll move to the next slide. What is high voltage engineering? It is the science of planning and operating and testing the high voltage electrical devices and designing the installation coordination for the reliable operation of all the power system equipments. And what is the high voltage value? For AC circuits, when the devices or line carries more than 1000 volts, it is the high voltage value. And for DC circuits, if it is 1500 volts, and what is the low voltage value? If the voltage level for AC circuits is 52,000 volts, and for DC circuits, it is 120 to 1500 volts. This high voltage transmission lines delivers electricity for long distances, and we are using this high voltage transmission because of the amount of energy loss during this high voltage transmission is reduced. And what is the causes of over voltage is electrical power system? The main causes are the external over voltage and internal over voltage. And the main causes of this over voltage is due to lightning surges and switching over voltages. Now we'll see what is lightning over voltage. It is due to the natural phenomenon lightning. And what is switching over voltage? It is due to the disconnection or connection of the circuit breakers during the fault interruption or initiation. We are coming across a high voltage known as across the circuit breakers. So what is the over voltage in electrical power system and how to overcome it? We have gone through. Now we'll see how the charge formation is taking place in the cloud and the mechanism of cloud formation. So this is your cloud diagram. So in an active thunder cloud, the large particle possesses the positive charges and the smallest particle possesses the negative charges. And this, the base of the clouds is the negative charges, and the upper base of the clouds forms the positive charges. When a charged cloud passes over the earth, it induces equal and opposite charges on the ground below. The cloud and the ground forms two plates, and they form as a gigantic capacitor and the dielectric medium in the air. So consider the two negative charge centers in the cloud. When an electric field intensity in the cloud at particular point and the charge concentration of the cloud exceeds the breakdown value of the moisturized ionosphere, an electric streamer with plasma is introduced. This you can see the diagram of the electric streamer, it is introduced. And this velocity is about 1 by 10 times the breakdown strength of the air. And the current streamer or the current of the steamer is 1000 amps. The downward streamer towards the ground is formed, and the negative charges on the base of the clouds are lowered down the steamer. The steamer progresses about 50 meters and comes to an halt, emitting a bright flash of light at its head. This halt is due to the insufficient build of charge, and its head is not sufficient to maintain the field gradient for the further progressive of the steamer. Now again, after a short interval of time of about 100 microseconds, the steamer again starts repeating its performance, and it proceeds in this manner and it reaches the water through a quick path, depending upon the condition of the air as well as the electric strength. The branch or there are many branches are likely to form in the streamer pointing towards the earth. Now, from the tip of the discharge, a pilot streamer starts with a low luminosity, and the initial streamer progresses by a series of jumps and is referred to as stepped streamer. The total time required by the stepped leader to reach is around 20 microseconds. Now we'll see what is written streamer. Now, when the leading streamer travels down and it forms a channel path and it becomes a good conductor on the surface, and this path, original path on the cloud base. Now, lowering to the cloud charges, it produces a strong electric field between the leader and the earth. And this channel reaches near the ground, a positive streamer springs out of the ground and rushes upwards. And you can see in the diagram of the positive streamer. This heavy current of 1 kiloamperes or more than 20 kilometers flow up the path of the stepped streamer. And the duration of the return stroke may be from a few microseconds to 100 microseconds or more, and it is neutralize the charge centers in the cloud during this period. It's, you can see the charge in the cloud is neutralized by the positive charges of the return streamer. This return stroke is very fast and it is responding for the low voltages. The first charge center is completely discharged and the streamer begins developing in the second charge center. This return stroke is followed by several strokes, and the leader of the second and subsequent strokes is known as dark leader. Now, the second charge center is discharging to the ground through the dark leader, distributing the negative charges along the path. The positive terminals are going up from the ground, and this heavy return stroke begins to discharge negative charge under the cloud and the second charge under the cloud. The discharge takes place within the cloud is known as sheet lightning. The total time it is required for the step leader to reach the ground is about 20 microseconds. Now, since the progress of this leader stroke is a series of jumps, it is referred to as stepped leaders. Now, the current carried during the lightning is about 1000 amps to 250,000 amps. Thank you. This is about the mechanism of lightning. Thank you, everyone.